Okay, calculation has been going on for about 10 to 12 minutes, and all the tool paths are calculated. It's going through and calculating up the remaining stock. We can turn off some of these tool paths and take a look at the result. Alright, the first thing I notice is that I got a couple of red X's here. So just like in the real world, probably you'll forget a couple of things maybe for the templating. And here it says the set equals open contour. So what it is that toolpath is supposed to swerve cut this front face and swerve cut this back face, but I forgot to chain the contour and put it on the set. So it's no big deal. We'll go to the CAD side. Let's hide this face, and we're going to go to composite curve, and we're going to chain this front edge. And I want to add some fillets to that contour because this is really going to end up being a tool path. So I want nice flowing motions. Alright, so there's one contour. We flip it around, do it again over here. Add the corner fillets. And then we're going to go to the Sets tab. And we're putting that contour and that face on that set. And same thing with contour 1. We're adding that contour and that face. Alright, and now we have what we need. Let's go back to the cam side. You notice we still have calculation taking place here. It's perfectly fine. And we're going to launch these two. And these two. Alright, and even while this calculation is happening, this one went ahead and got created, as did the back one. And that's because the toolpath calculation is multi-threaded, which means it creates different tasks and assigns them to available processors in the computer. So you can have, a dozen processors, or who knows, it's only limited by the hardware, but as many processors as your computer has, it can divide up tasks and send them to each processor. Cimatron also has a Superbox license, which allows for a network calculation device to sit on the network and to take all the tough calculation tasks off the workstation, send it across the network to a calculation device. All the hard work is done there, and it's sent back to the user. Alright, so let's have a look at what this one does. We'll go to the navigator. So basically it's just a swerve cut across that front face. But Cimatron is very powerful. Pretty much any kind of toolpath motion that you can imagine, you can make happen. Alright, so let's see what else we got here. We got the first rougher being done on the top. It's done with a 1-inch cutter, and if you look at the remaining stock, you can see that 1-inch cutter was not able to get in everywhere. but that's fine. The software is very intelligent. It's always tracking the remaining material. So here, when we go to a 1/2 inch cutter, we'll see that that's getting into these pockets now, and it's going to be doing ramping motion. You can kind of see it here. We can set the ramp angle, and it comes in and roughs these pockets out. And if we look at the remaining stock after this one, it's going to look like that. Alright, these local 3X are the ones that we just looked at. And then we got the finish mill all. Now this one is basically cutting everything with a ball cutter that's not flat or horizontal. So it's putting on the chamfers, it's hitting that fillet, it's doing this contour work. So basically all the 3D stuff. And then we got a roughing tool path with a 1/4 inch tool going in and picking out corners. Then this is basically a copy and paste of that procedure, where we just change it to floor milling. So it goes in and it's cutting the walls to within 10 and the floors to within 5. So it's basically like a floor milling procedure. And then we go from 10 on the walls and 5 on the floors to just 5. And again, this first tool path, we're not taking it to 0, for like stress relief type conditions. And then this one, I believe, is a 1/8 cutter. And what's nice about this one is that it's using multiple cutters. So if we go to the navigator, let's take a look at it. So here's a 1/8 cutter, where that length of tool is good for probably 99% of the job, but there's a couple areas where that length is too short, and so it takes it down as far as it can, just about where the tool holder would start colliding, and then it's capable of grabbing a longer cutter and going in and finishing those lengths. And it does that automatically in the software. It's a very nice feature. You can have up to 6 different lengths of the same cutter and tell it to go cut a job. So you can have a short rigid cutter, a standard length, an extended length, and a stupid extended length, all with different downstep, RPM, feed rate, all independently controlled within the same one procedure, all divided up according to the software. Okay, so now I think we're cutting the other side, and everything here's pretty much the same as what we saw before. The only difference is that I want to show what the remaining stock looked like from side 1. You can see, probably better if we look at it from this side. So from the top side, we had that Z stop surface. Let me change the color. This is kind of hard to see. That should be a little better. Alright, so here you can see the stock that was left from side 1. And when we calculate side 2, it only cuts where it knows there's material. It's not going to waterfall down where there is not stock existing. So it's very intelligent about remaining stock. We go through the same rough and then re-rough as before. The one thing that I want to show that's a little bit different, I think it's all the way down here. So getting into the finishing procedures, we have a 1/2 inch cutter. This is a 1/2 inch ball. Just machining this bottom side. We'll go to the navigator and just kind of show that ball cutter is not going to get up against that edge. We're leaving a lot of material here, right? So we got to come back and machine this cusp that's going to be left over. And Cimatron's remachine is very powerful. I went from a 1/2 inch ball to a 1/4 inch bowl cutter, and if we go to the navigator, we'll see that that's just going to come in and machine the leftover material that the ball cutter would have left. And I probably put a little bit of overlap in there, so it might be cutting a little bit more than it needs to, but I'd rather err on the side of caution and let it cut a little bit more, making sure we don't leave anything. But that's an excellent remachine procedure, going from a ball cutter to a bowl cutter. Alright, and then if we look at the 2-axis pockets real quick, going back to the top side, these are 2-dimensional with cutter comp pockets. They're all done automatically. I didn't tell it what the Z top was, what the Z bottom was. I did ask for a step in the Z, and that's why I've got 2 different motions in the Z value. It could have been just 1 pass if that's what I wanted, but the output will be G41 with cutter compensation because it is a 2D procedure. And then we've got the open profiles, and the open profiles are smart enough to start on the outside, do a nice little arc in and an arc out. But you saw me do all the preparation work for these. It was just a matter of using the NC pocket manager, and it was able to automatically program 2D pockets. The automated drilling is really awesome. You saw me program all of this. The programming is pretty much automatic when it comes to drilling. Alright, well, thanks for watching.